uselessly in the dirt. What if I told you the bulldozer's greatest secret has nothing to do with its own weight or the raw size of its 850 horsepower engine? What if the real story is about how it masterfully manipulates the laws of physics? This isn't just a big, dumb machine. It's genius and cleverly engineered to solve a series of immense physical challenges. We're going to reveal the 5 secret physics tricks that allow this machine to push loads many times its own weight, turning brute force into a scientific art form. Secret number 1, the foundation of force. Let's start with the absolute first requirement for any impossible push: grip. Unbreakable absolute grip. A giant Cat D11 dozer weighs over 115 tons, or 230,000 pounds. If you or I try to push something immensely heavy like a car, our feet would just slip on the pavement long before we could apply any meaningful force. We'd lose our battle with friction. So why don't this machine's massive steel tracks, turning with the force of an 850 horsepower engine, just spin uselessly when it puts its shoulder into a 1,000-ton rock pile? The secret is a brilliant paradox of physics: ground pressure, or rather, a strategic lack of it. To get the ultimate traction, you need the ultimate contact with the ground. Every single grouser or steel bar on those tracks needs to bite into the earth. You might think that with all of its incredible weight, a dozer would immediately sink, digging itself into a hole the moment it tried to move. But those enormous tracks are engineered to function like a pair of giant snowshoes. They distribute the machine's immense weight so perfectly over such a large surface area that it barely presses down. For all its bulk, a large dozer can exert a ground pressure of only about 15 to 20 pounds per square inch, which is astonishingly similar to the pressure exerted by your own feet. By floating across the ground instead of digging in, the dozer keeps the maximum possible traction area in contact with the earth at all times. This maximizes static friction, the force that prevents slipping and is always stronger than kinetic or sliding friction. This delicate balance is the entire foundation of its strength. It means that every last ounce of power generated by the engine and multiplied by transmission can be translated into forward-pushing force, drawbar pull, not wasted on trying to stay afloat or digging itself into a rut. Secret number 2, the force multiplier. Okay, so the tracks have established a seemingly unbreakable grip on the earth. But where does that actual force come from? An 850 horsepower diesel engine is incredibly impressive, but that's not what's providing the final world-shattering push. Horsepower is about doing work quickly, but pushing a mountain doesn't require speed, it requires torque, a pure, massive twisting force. If you hook that engine's high-speed rotation directly to the tracks, they'd spin at hundreds of miles per hour and instantly lose their grip. The real secret is a concept that has been used for centuries, perfected to an incredible degree inside the bulldozer: torque multiplication. Hidden deep within the bulldozer's powertrain is a series of planetary gear sets. Picture a central sun gear spun at high speeds by the engine's drive shaft. This gear turns several smaller planet gears that orbit around it. These planet gears are, in turn, held inside a larger, stationary outer ring gear. This entire assembly is an engineering miracle designed to do one thing with ruthless efficiency: trade speed for power. It works just like the lowest gear on a bicycle. When you're struggling up a steep hill, you shift down. Your feet pedal faster, high speed, but the wheel turns slowly with enough force to conquer the incline, high torque. The planetary gears do the same thing, but on a monstrous scale. The planet gears are forced to turn much, much slower than the central sun gear, but with many times the twisting force, or torque. The design is incredibly compact and strong because the immense load is shared across multiple gears at once, instead of just 2. This massive gear reduction is how the engine's raw horsepower is turned into a slow, patient, and seemingly unstoppable push that is far, far more powerful than the machine's own weight. Secret number 3, the liquid power transfer. But this creates a new, potentially catastrophic problem. Multiplying force with gears is great, but trying to connect that unstoppable, slow-moving power to an immovable object like a 1,000-ton pile of rock is a recipe for disaster. With a direct mechanical link like a clutch in a car, something has to give. The moment the blade hits the rock, an irresistible force would meet an immovable object. Either the engine would stall violently, or the immense shock wave traveling back through the solid steel gears would shatter them, twist the drive shafts, and destroy the transmission. To solve this, engineers built in a brilliant hydraulic buffer, the torque converter. Think of it as two fans facing each other inside a sealed donut-shaped housing filled with transmission fluid. One fan, called the impeller, is connected directly to the engine. The other fan, the turbine, is connected to the gears and tracks. There is no physical metal-on-metal connection between them, only the fluid. As the engine spins the impeller, it whips the oil into a powerful swirling vortex. This vortex of fluid then strikes the blades of the turbine, causing it to spin. This fluid connection is the key to applying massive force smoothly and safely. It allows the engine to rev up to its maximum power band while the tracks are moving slowly, or are even completely stopped. When the dozer's blade hits the unmoving pile of rock, the fluid inside the torque converter absorbs the massive shock, preventing the engine from stalling and protecting the entire drivetrain from being destroyed. Even better, the fluid dynamics inside the converter, thanks to the third component called the stator, naturally multiply the torque when the difference in speed between the two fans is greatest. It's a liquid heart that is both a shock absorber and a secondary force multiplier, allowing the dozer to patiently build and apply relentless, ever-increasing pressure against a load that would break any normal machine. Secret number 4, the art of the angle. Now, let's look at the business end of the machine, the blade. Pushing 1,000 tons of material isn't just about raw force, it's about intelligently managing that load. If you just tried to shove a giant flat plate of steel into a pile of dirt, you would create so much friction and resistance that even the most powerful dozer would be stopped dead in its tracks. You aren't just pushing the material, you're fighting the internal friction of the entire pile. The deep continuous curve of the dozer blade is a work of geometric genius. It's scientifically designed to make dirt and rock roll as the dozer pushes forward. Instead of compacting the material and trying to force it ahead like a battering ram, the blade shape lifts the material at the bottom and curls it over onto itself. This rolling action dramatically reduces friction and internal resistance within the material being pushed, allowing the dozer to move at far greater weight with the same amount of power. The large wings you often see on the side of a U-blade simply keep this massive rolling load contained, maximizing the efficiency of every ounce of force the machine generates. But what if the load isn't a pile of loose material but a single solid object, like a rock ledge or frozen ground? For that, the dozer uses strategy. At the back of the machine is the ripper. This giant claw or set of claws is used to concentrate the dozer's entire weight and pushing power onto a few tiny hardened steel points. It's the machine-sized equivalent of using a pickaxe to break up hard ground before trying to move it with a shovel. It's a strategic tool used to fracture and break up an impossible push into a series of smaller, possible rips. The dozer first prepares the ground with the ripper, turning a solid, breakable mass into manageable chunks. Only then does the blade come in to efficiently move the now manageable load. Secret number 5, the unbreakable foundation. Our final secret is what ensures all of this multiplied and masterfully managed force actually makes it to the ground without interruption. The elevated sprocket, also known as the high drive system. On older bulldozer designs, the drive gear, the sprocket, that turns the track, was positioned low to the ground, right in the roller frame. This meant it was constantly being battered by rocks, submerged in mud, and absorbing every single shock and impact from the rough terrain. This not only caused constant, expensive breakdowns, but also meant that the power flowing to the tracks was disrupted by vibrations and flexing of the drivetrain. The system was vulnerable exactly where it needed to be strongest. The revolutionary solution, pioneered by Caterpillar in the 1970s, was to lift that critical drive sprocket high up, away from the chaos happening on the ground. This created the iconic triangular track shape you see on many modern dozers. This high drive design accomplishes two brilliant things at once. First, it completely isolates the entire powertrain, the engine, transmission, and final drives from the harsh ground impacts. The power delivery components are protected, making the system incredibly durable and ensuring that the pure, uninterrupted force generated by the engine makes it smoothly to the tracks. Second, it allows the track frame to flex and oscillate independently, following the contour of the ground. This keeps more of the track on the ground at all times, especially on uneven terrain, providing the superior continuous traction we talked about in our very first point. It's the final crucial piece of the puzzle. The high drive is the unbreakable backbone that guarantees that the immense multiplied force has a solid, perfectly connected, and incredibly durable platform to push from. Conclusion. So, the next time you see a bulldozer effortlessly carving through the earth, you'll know its true secret isn't about big engine or heavy frame. You'll know that you're not looking at a machine built for brute force, but an elegant, interconnected system designed to create and apply superhuman force. You'll see the tracks using a paradoxical lack of pressure to achieve ultimate grip. You'll visualize the planetary gears silently spinning inside the steel housing to act as a massive force multiplier. You'll understand the torque converter using fluid as a shock absorber in a perfect power delivery system. And you'll appreciate the blade and ripper not as simple tools, but as instruments for clearly managing and disassembling impossible loads. And finally, you'll see that a high drive triangle, the unbreakable backbone ensuring all that incredible power gets to the ground no matter the conditions. The bulldozer isn't a brute, it's a master of physics, using 5 ingenious scientific principles working in perfect harmony to multiply its strength far beyond anything its size would suggest, allowing it to move the world one push at a time. See you next time.